Let's now look at question number 11. Two runners take part in a race. The graph shows how the speed of each runner changes with time. What does the graph show about the runners at time t? Well, it's a speed-time graph, and at time t, they're both quite clearly travelling the same speed. Now, to say that runner 1 has zero acceleration quite clearly isn't correct. He has constant acceleration. Runner 1 is overtaking runner 2. Well, you don't know that unless you know the distance that they've travelled. And runner 2 slowing down. No, he is not slowing down. Basically, the runner is heading towards moving at a constant speed. So the answer here is A. Number 12. A coal-fired power station generates electricity. Coal is burnt and the energy released is used to boil water. The steam from the water makes the generator move, and this produces electricity. Which words are used to describe the energy stored in the coal and the energy of the moving generator? Well, inside the coal there will be chemical energy because that's what allows it to burn. And the moving generator, there's a hint there. The fact that it is moving, it is kinetic. Hydroelectric is another form of energy, or an energy power station if you like. So here it is kinetic. So the answer is B for ball. Question number 13. Diagram 1 shows a measuring cylinder containing water. Diagram 2 shows the same measuring cylinder and the water after 10 identical solid glass spheres have been added. The mass of one of the spheres is 10 grams. What is the density of the glass from which the spheres are made? Now guys, density equals mass divided by volume. And what we've got here is a volume of 70 and a volume of 30. So 70 minus 30 is 40. But that's not for one sphere. That is for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 40 centimeters cubed is the volume of 10 spheres. So if we divide that by 10, we can find the volume of 1, which is quite clearly 40 divided by 10, which is 4. And it says here that the mass of one sphere is 10 grams. So density equals mass divided by volume. 10 divided by 4 is 2.5 grams per centimeter cubed. So the answer is C. Question number 14. A child sits on a rubber ball and bounces up and down on the ground. What stays the same when the ball hits the ground? Now this often causes confusion. It's the mass of the ball that stays the same. If it's a rubber ball and it's bouncing on the ground, the shape will not be staying the same. If it's bouncing up and down, its acceleration is not going to be the same because it'll be changing direction. And its velocity certainly won't be staying the same either. Because it's made of rubber, obviously it will compress, so its shape will change as well. It can also stretch out and elongate. So the answer here is B for ball. The mass of the rubber ball will not change. Number 15. Which quantity is measured in Newton seconds? Ft equals mv minus mu is the formula for impulse. Impulse is measured in Newton seconds or kilogram meter per second. So quite clearly here for number 15, the answer is A. Because moment is Newton meter, not momentum. Power is watts and work done is joules. Question number 16. The graph shows how the speed of a van changes with time for part of its journey. In which labelled section is the van decelerating? Now decelerating means slowing down. The only region where this van is slowing down is in region B. In region A, it's travelling at constant speed. In region C, it's stationary, and in region D, it's constant acceleration. Region B is constant deceleration. Question number 17. 4 different children run up the same set of stairs. For which child is the useful power to climb the stairs the greatest? Power equals work done divided by time, and work done equals force times distance. Here, you've only been given the mass of the child. So what you do is you change the mass of the child into force by multiplying it by 10. And we don't actually know the height of the stairs, but what we know is work done is force times distance, and the distance for each of the students is going to be the same. So how do we get the greatest work done? Well, the greatest work done will be for the student with the biggest mass. And to have the greatest power is work done divided by time taken, we're also looking for the least amount of time. Since they're inversely proportional, smaller time means greater power. You're using more energy per second. So quite clearly the answer in number 17 has to be D. Number 18, the diagram shows a cuboid made of metal of density 2.5. What is the mass of the block? Mass is density times volume. They've given you the density. Your job's to find volume by doing length times width times height. 10 times 2, which is 20. 20 times 2, which is 40. Mass equals density times volume, 2.5 times 40, and you'll get the answer to be D. Number 19. A large stone is dropped from a bridge into a river. Air resistance can be ignored. Which row describes the acceleration and the speed of the stone as it falls? Well, gravity for every object is the same. And what gravity does to an object, if there is no air resistance, it will make the object accelerate. In other words, it'll get faster and faster and faster. Now, because gravity is the same for all objects, and there is no air resistance here, the acceleration will be constant. So since there's constant acceleration, what happens to the speed of the stone? It gets bigger. So the answer here has to be B. Question number 20. Which energy source is one that is used to boil water to make steam in power stations? Tidal, wave, and hydroelectric and nuclear all involve water. Tidal involves the water coming in and out from the shore a couple of times a day. Energy from waves is wave energy out in the sea somewhere where the waves bob up and down, turning with a turbine. And hydroelectric is normally found in high up areas or in big rivers where the GPE gained by the water turns into kinetic energy as it's made to fall through a pipe. The only one that heats up water here is nuclear. The answer is D.